Hello class, today we're doing lesson 11.4, mean absolute deviation. So again, what we're dealing with is mean, and we see that word absolute. Do we remember any other math term that we've learned this year that has to do with the word absolute? Yes, Izzy got it right, absolute value. So we're gonna probably, hint, hint, be dealing with absolute value a little bit in this. So let's go forwards. So here we have this, basketball. The tables show the number of points two teams scored. So we've got Allie's team and we've got Lena's team. So in your books, it's on page, it's on page 837. What you're going to do is you're going to plot those points of each set of data. So for Allie's team, if we were plotting it, first the easiest is just 52, 48, we got 60, we got 50, we got 56, we got 54, we got 58, and we got 62. Wow, that was a lot of work just for them all in a line. Then let's see, in Lena's team, here we got 51, we have 48, we have 60, we have 49, we have 59, we have 50, we have 62, and we have 61. So this one looks a lot different than the other one. If you notice, they're a lot further apart from each other, but the numbers themselves are grouped much tighter. So each of these first ones is a whole integer apart as opposed to Lena's team, which is only half apart. So let's see. Find the range of each set of data. So we learned about range before, and what is range? Who can tell me? Lucy, what do you think range is?
The values between the beginning of the data set and the end of the data set.
That's really good. So that's a really good way to do it, but there's one thing. The beginning of this data set, I'd say, is 52. That's the first one, and the end is 62. Is that how we do it, though? This one, the beginning is 51 and the last is 61. Is that how I do it? Yes, Daniel.
You have to put it from least to greatest one.
Exactly. So as Lucy said, it's the difference between the first one and the last one. And as Daniel said, in a sorted set between when it's smallest to biggest. So essentially, it's the biggest number minus the smallest number. So let's look here. The biggest number in this one, we have 62. And the smallest number we have is 48. So the difference between 48 and 62 is, so for her team, I'm just going to say it is 14. I know you guys can count, so I don't want to take up too much of our class time doing that. Then for Lena's team, our biggest is going to be this 62, and our smallest is also going to be 48. So it's 14. Is it always the same? Do they always have the same range? No. No two sets of data always have the same information unless they are the exact same numbers. That's it. They could have very similar. They could have the same answers for range. They could have the same answer for median, but that doesn't mean that they're the same set of data. So refer to the number lines. Compare and contrast each side. We see this. If we looked at the mean of the first one, we literally go straight to the middle. 1, 2, 3, 4. 1, 2, 3, 4, which means that our mean is going to be right there, which is 55. As opposed to this one, which we have to work a little bit harder to get, but it still works. 1, 2, 3, 4. 1, 2, 3, 4. Let's go to the center. It's not this, not this, not this, not this, not this, not this. Oh, it's right there. Oh my gosh, it is 55 as well. Once again, does that mean that it's always 55? No, it does not. And like I said earlier, Lena's team is far more spread out. Allie's team is far more close together in general, but of the points, Lena's team scored points that are much tighter together. So that's the compare and contrast. Find the mean absolute deviation. So you have to use, or you have used the interquartile range, which is the IQR, it's kind of hard to see, to describe the spread of a set of data. You can also use the mean absolute deviation. The mean absolute deviation of a set of data is the average distance between each data point and the mean. So literally, it is the average of the average. It is the average of the mean. It is trying to make it as average as possible. So if we looked at this one, so if you're looking at this one, the table shows the maximum speeds of 8 roller coasters. Find the mean and absolute deviation of the set. If we're finding the mean, is it important that we put it in a specific order? Perfect. Everyone who answered, the exact answer is no. We don't have to worry about it when it's mean. We have to worry about it when it's median. They do sound very similar, but mean just means average. The only time you ever need to organize your set of data from least to greatest is median. It's the only time. However, I do find it easiest to organize later because it just makes it easier to look at. So find the mean. What we do when we find the mean is we add up all of our data points. So we added up 58, 88, 40, 60, 72, 66, 80, 48. And there's 8 different numbers. So we divide it by 8, the number of numbers. And we get our average to be 64. So then they plotted the points. You don't necessarily have to plot them, but if you're a visual learner, plotting it is very, very helpful. So they plotted these points on a number line and pointed out where the mean was. And you see all these numbers. So you see those numbers. And what happens is we want to see what the difference is to each side. So here, if our mean is 64, to get to 40, it's 24. To get to this point here, right there, 88, it's also 24. So we see this, that's the mean. It should be spread out. So what we do is we add the average of all of them. So this one is 24, 16, 6, 4. So we have that on this side. Then we have 2, 8, 16, 24. So we add those as well. Once again, there's still 8 numbers because we still have 8 plot points. And we find out that the mean of the mean, or the absolute deviation of the mean, is 12.5. So the mean absolute deviation is 12.5. That means that the average distance each point value is from the mean is 12.5. That's the average distance that it is. Now you might be thinking, okay, why does this matter? And even I was thinking, why does this matter? But we're going to go and see why. So the table shows the speed of 10 birds. Find the mean absolute deviation of the data. Round to the nearest hundredth. Describe what the mean absolute data represents. Dominic, how many different numbers do we have here? Instead, Liana, how many different numbers are there?
There are 10 different numbers.
Perfect. So the easiest thing that I ever do is I just always find that first. And I know, whoop. So I already know I'm going to be dividing by 10. Excellent. So then I have to add up all of those numbers. Has anybody added up all of the numbers yet? Excellent. Lucy and Caesar both say it is 786. Perfect. So when we find the mean, we find that it is, and this is so easy. I'm going to move my decimal over to 1 because everything over 1 is a whole number. Here, it becomes 78.6. You could also use your calculator to divide, and you find that it is 78.6. So perfect, that's our answer, right? No, that is just our mean. The table asks us to find the mean absolute deviation. So now we have to find the difference between each number and this. So we have to find the difference. If we looked at it, I'm going to write this down just so we can see it. So we've got our numbers. We have 88, we have 77, we have 65, 70, 65, 72, 95, 80, 106, and 68. So we want to find the difference between each of these numbers. So all you have to do is subtract. Now, here's why it's called absolute deviation. Because I want to subtract one from the other. for example, I want to subtract the number here from this number. But what happens when I subtract 88 from 78.6? What happens when I do that? What number does it give me? Exactly. Caesar and Hannah are right. It gives us a negative number because we're subtracting a bigger number from a smaller number. But when we do absolute value, our answer always comes out positive. Always. That's just the way that we avoid getting negative values because birds can't fly at a negative speed. Well, that doesn't make sense. So that's why it's called absolute value deviation. Now, you don't have to necessarily do it like that. You could just remember to subtract the bigger number from the smaller number, or the smaller number from the bigger number. Really, that's it. You can just do that. So for Daniel, he had this one. He got 6.6. Excellent. Caesar had the 65. He got 13.6. That's also here. 13.6. Excellent. Perfect. Jasmine got 10.6. Isis got 27.4. Excellent. Perfect. Dominic got 16.4. Excellent there. Tobias got 8.6. Excellent work. Perfect. Brendan got 1.6. Excellent work. Perfect, Ani. You get 9.4. Liana, what is the answer? Oops. What's the answer?
1.4.
Excellent. So now that we've found all of our answers, what we do, just like before, I know this seems so stupid, is we add up all of those stupid answers that we got and divide by the number. It's the same exact number. So no matter what, when we add all of these up, we're going to be dividing by 10 because there's still 10 numbers. So use your calculator, and the numbers we're adding up are these numbers now. I know. It's so much work. I know. So you're just going to add up together the 9.4, 1.6, 13.6, 8.6, 13.6, 6.6, 16.4, 1.4, 27.4, and 10.6. You are going to add all of those together, and then there's 10 different numbers, and since we're finding technically the mean of the mean, we divide by the number of numbers we have, so it is divided by 10. And what number did you get when you added them all together?
Altogether, I got 95.8.
95.8. Let's see if that's correct. I don't think so. Maybe it is. I don't know. Is this A? I feel like we're not going to get that. I feel like you're a little bit off. I think it's a tiny bit off. Sophia got it. It is 109.2. Excellent. So Sophia got it. Once again, when we divide by 10, literally we can just move our decimal over like that. If you don't understand that, just divide by 10. So we get 10.92. That's our mean absolute deviation. All of that work, that's the part that matters. We got 10.92. So our mean absolute deviation is here. It is that 10.92. That means on average, each point is about 10 and 92 hundredths away from our mean. Literally, that's all it means. Honestly, you can compare the mean absolute deviations for two data sets. What that means is essentially you're just seeing which one has a bigger mean deviation, which one has that. You can see that. So the top 5 salaries and the bottom 5 salaries for the 2010 New York Yankees are shown in the table below. Salaries are in millions of dollars and are rounded to the nearest hundredth. It's not really necessarily that important that we know it's in millions of dollars, except it's a good fact to know. That means the first one is $33 million. $24.29 million, because it's hard to say 24 and 29 hundredth million dollars. I don't know. I don't like saying that. So if we look at this chart, find the mean absolute deviation for each set of data. First, we have to find the mean. Our first step is to find the mean. okay? And look, it's only really a 2-step process. It's just a long process. So what we do here is, this is the process essentially. We add up all of the numbers. It doesn't matter. We don't have to sort them because we're just finding the mean. So we add them all up. And for our answer, when we add them all up, how much are we dividing by? What number are we going to be dividing by? Perfect. Everyone said it. We're dividing by 5 because even though there are 10 numbers here, we're talking about the top 5 salaries. It literally says 5. So we're going to be dividing by 5. When we add them all up and divide by 5, we get about 23 and 4/10 or 40 hundredths as they wrote it. So then the mean is about that much. That's the mean. Find the mean absolute deviation of the top 5 salaries. So we already see it. If I did the subtraction between them, because I just am going faster, it would be 33 minus this amount, which gives us that. It would be 24 and 29 hundredths minus this amount, which gives us that. It would be 22 and 60 hundredths minus that, which gives us this amount in absolute value form. It'd be 20 and 63 hundredths minus that, and we get that amount. And it would be 16 and 50 hundredths minus this, and we get that amount. So we get all of that, and then we do the exact same thing. We add all of those up because it has that word mean. The absolute just meant to make sure they're all positive. So we add them all up and we divide. Still, there's 5 numbers, and we find the mean absolute deviation is about 4.19 million. So that's the difference between the top 5 salaries. Approximately, it's 4.19 million. Then we find the mean of the bottom 5 salaries. We just add up all of them. Again, it says 5, so we know we're dividing by 5. It's in the book, so if we added them all together, we get about 0 and 43 hundredths. So the mean is about that. The mean absolute deviation, again, how do we get the numbers for the mean of that mean? Madison, how do we do it again?
You, from the numbers, you take away the already mean.
Excellent. Excellent. Exactly. So from the numbers that we have, our OG original numbers, we subtract the mean. Absolute value it, which means it's always positive. By the way, if you don't want to absolute value it, an example would, so we find it. 0 and 45 hundredths, 0 and 43 gives us that 0.02. 44 gives us 0.01. 43, it's the exact same. 41 and 41. We divide by 5, we add those all together, and we get that much when we divide. So the mean absolute deviation for the other one is only about 0 and 1/100th million dollars. That's it. That's how you do it. It's just the mean of the mean. As I mentioned earlier, it's called mean absolute because it's subtraction in absolute value. So we see that on the side right here, it's subtraction in an absolute value. What that means again is that it can never come out negative. It must come out positive. So when we do this, so that's why we get the same numbers each time, because it's an absolute value. It always has to pop out positive. So regardless of which order you do, notice I switched those orders. Because it's an absolute value, it must pop out positive. So we're going to do this one. The table shows the running time in minutes for 2 kinds of movies. Find the mean absolute deviation for each set of data. Round to the nearest hundredth. Then write a few sentences comparing their variation. First things first, we got to find our means for each of them. So I'm going to be dividing each of these by 5 because there's 5 numbers. 90 plus 95 plus 88 plus 100 plus 98. We divide that by 5. That means that our mean for this one, our mean we got is 94.2. So the mean for drama, again, we add them all together. So we get 115 plus 120 plus 150 plus 135 plus 144. That's 664. We divide it by 5. So the mean for this one is 132 and 8/10. So a lot of you got those answers, which is really great. So that's how we find our mean. But we need to find the mean absolute deviation. What that means, again, is we're going to subtract each of these numbers individually from this number. So we add all of those numbers together, and at the top we get 20 and 8/10. We divide it by 5, and we find our mean absolute to be 4 and 1/16. So I want you guys to do the same for drama. You're going to subtract this number from this number. You're going to subtract this number from this number. You're going to subtract this number from this number. You're going to subtract this number from this number. And you're going to subtract this number from this number. So when we do this, we get 17.8 plus 12.8 plus 17.2 plus 2.2, and I'm going to do a plus, and it's on the other side, the 11.2. Excellent. So I just did it like that. We organized. We add all of those up. For our top, we get 61 and 2/10. We divide it by 5, and we get our answer to be 12 and 24 hundredths. So this is the mean deviation for drama, and this is the mean deviation for comedy. That's how we do it. And that's all it takes to find the mean absolute deviation. You find the mean, you subtract all of the numbers from the mean, you add all of the numbers up to find the mean again, and that's it. It's mean, subtract from mean, mean. Mean, subtract from mean, mean. Mean, subtract from mean, mean. So, if we found this one, find the mean absolute deviation for the set of data. To find the mean, it's 112 plus 145 plus 108. I'm just adding the numbers. Plus 160 plus 122. There are 5 different numbers. So our mean is 129 and 4/10. That's our mean. Then we have to find the difference between all of them. There's still 5 numbers. So we get this 129 and 4/10 minus 112. Gives us 17.4 minus that 145 gives us 15 and 6/10. Minus 108 gives us 21 and 4/10. We get minus 160 gives us 30 and 6/10. And then minus 122 gives us 7 and 4/10. We add all of those together. We get our answer here to be 92 and 4/10 divided by 5. So our answer becomes 18 and 48 hundredths. All you have to do, you do the mean. Then you do subtraction between the mean and our original numbers. And then you find the mean of that. So the mean absolute deviation, there we go. It's 18 and 48 hundredths. Here, if we did this again, it's the height of a water slide. So again, we're going to be finding the mean absolute deviation. First, we find the mean. So first, we got to find the mean before we can find the mean absolute deviation. To find the mean, we add all of our numbers up and we divide by the amount of numbers. We add all of the numbers up and we divide by the number of numbers. If you're struggling with this, make sure that you go back and check your work from the lesson 1. Period 4, Caesar got it right. So he got 116 and 6/10. The period 1, Jenna and Daniel, we got 89 and 6. Excellent. Those are the means. Those are the means. Then we do the subtraction between them. So we have the mean. We got that 89 and 6/10. And then we subtract 75. We find our answer. Then we subtract 95 and find our answer. And then we add all of those up together. So when we add it up for the Splash Lagoon, we're gonna get 51 and 6/10. For the Wild Water Bay, when we add it up, we get 62 and 4/10. And all we gotta do is divide. For Splash Lagoon, our mean absolute deviation is 10 and 32 hundredths. For Wildwater Bay, we get 12 and 48 hundredths. And that's all we gotta do. So yet again, the steps that we do, I'm going to write this down. You do. I'm going to write it a little bit better and a neater thing. So, first thing you do is you find mean. Subtract OG numbers from mean. Find mean of those numbers. That's it. That's it. Those are the 3 steps to find the mean of those numbers. All you got to do is you find the mean, subtract the OG numbers from the mean, and then you find the mean of those numbers. Essentially, it's mean, difference, mean again. Takes a little bit of time. Yes, it does. But after that, it's really simple when you use your calculator. So your homework is going to be page 841, numbers 1 through 9. Thank you, everybody.